So far, we've explored Jamf Protect and learned how to detect different types of threats. But what can we do once a threat has been identified? If malware is detected but not immediately mitigated, a malicious actor could complete their attack on a system and exfiltrate before the victim is even aware of the intrusion. Let's take a look at how Jamf Protect can block and safely remove threats from enrolled Macs, all without any manual action from an administrator. This is Zach. Welcome to Threat Mitigation and Alerts. Let's begin on the Jamf Protect dashboard. Before we start generating alerts, it's helpful to understand what an alert is and what information it contains. Navigate to Alerts in the sidebar. This page contains a continually updated list of alerts triggered on enrolled computers, starting with the most recent. If I remove the two filters at the top, severity is not equal to informational and status is not equal to resolved, we start to get a more complete picture of what Jamf Protect is monitoring on my enrolled Macs. Everything that is captured here, even seemingly innocuous things like screenshots being taken or data written out to a USB, corresponds to an analytic in Jamf Protect, and thus could be used in a malicious attack. Let's look closer at this alert for a screenshot. At the top, we have the timestamp of when the alert was triggered, the severity ranging from informational to high, the status of the alert in Jamf Protect, and which computer actually triggered the alert. The severity of the alert provides an at-a-glance check for administrators to see what alerts require immediate attention and which are more likely to be benign. This alert has none of the 3 pips filled in and is categorized as informational. Informational alerts are just that, a record kept for administrators of actions that are likely to occur in everyday use of a computer. More likely than not, this is not the result of a malicious actor capturing screenshots without the user's knowledge. Regardless, the record is kept in case investigation is needed in the future. The status of the alert is currently set as new, meaning no action has been taken by Jamf Protect. Administrators can change the status of alerts they are actively working on to in progress to help organization and avoid duplicated efforts. When the mitigation effort is complete, the record can be set to resolved and filtered out of the list on the alerts page. Moving down the page, we have a host of information about the computer and user that triggered the alert. We can see the computer's IP, a list of tags the alert is automatically assigned, and then details about the event. Each of the tabs at the top contains more detailed information about the event than the current summary tab that we are on. We can see the full process tree, view more information on the file, including its hash, more detail on the binaries that were used, and then additional information about the active user accounts at the time in Users and Groups tabs. The JSON tab contains all the information from the other tabs in an API-accessible form. Now that we know what an alert is and what it contains, let's return to the Alerts page. I can see a few alerts in this list that have a status of auto-resolved. These alerts are events that were immediately mitigated by Jamf Protect. Mitigation can happen in a variety of ways, and more advanced users will be able to take advantage of the integration with an MDM to create a cascade of actions that occur when an alert is reported. But for now, let's look at a couple examples of Protect's built-in automatic mitigation. Moving on to our test Mac that was enrolled in Jamf Protect in the previous lesson, I'm opening a browser and navigating to icar.org. This file, developed by the European Institute for Computer Antivirus Research, is a simple text document that safely activates most antiviral software without actually delivering a viral payload to your computer. If you are following along, please do not perform this step on a company-owned or production computer. Instead, use a test Mac to avoid upsetting your security team. I've downloaded the icar file and am opening my terminal window and attempting to execute it as if it were a binary file using the sh command and the path to the file. After executing the command, a Protect dialog appears that lets me know the file was blocked from running, has been quarantined, and reported to my IT team. Notice that the iCar file is no longer in my Downloads folder. Instead, the file has been sequestered in library/application-support/Jamf Protect/quarantine. If we head back into Jamf Protect, we can see that an alert has registered as expected for this computer and has a status of auto-resolved since the Jamf Protect agent has already blocked the file from running and quarantined it on the computer. After selecting the alert, we see similar information to the one we explored previously. This alert has a severity level of low, has logged my computer's IP, and under Threat Event Details, we can see that the alert was triggered because the icar.com file matched the icar_a known bad threat signature. Let's try again. This time, we'll use a custom prevent list to specify what software we want to keep off our enrolled Macs. I'm navigating to Threat Prevention, Custom Prevention Lists. Say my organization has had a problem with Macs running torrent software on company-owned devices, BitTorrent in particular. I'm clicking Create Prevent List and giving this list a name. We can block specific files using either the file hash or signing information. I'm using signing information. Since I already know the file's signing identifier, I'm selecting that option and entering the identifier in the field below. com.bittorrent.btweb. For more information on how to determine a file signing information, see the Jamf Protect documentation link in the resources. That's all the information needed to prevent the torrent client from running, so let's click Save at the top of the page and head back over to our enrolled Mac. We've got the torrent client downloaded already, so let's install it and attempt to use the software. Again, we are immediately blocked and the app has disappeared from my applications directory. Reinstalling or renaming the app results in the same behavior. The files are now quarantined in library/application-support/Jamf Protect. And as you can see, the folder is unreadable for my user account. Through some terminal magic, I can now access the folder, and we can see 3 directory names with unique identifiers, one for each of my quarantined files. Opening these exposes the quarantined file. Any modification to this quarantine directory causes the Protect agent to delete and recreate the directory with the correct permissions. And shortly, the directory is once again inaccessible and my quarantine files are now deleted. Moving back into Jamf Protect, we now have new alerts with a status of auto-resolved. Clicking either of these shows us additional information about the alert, and we can see under the event details that the match happened because the file signing ID matched the identifier from our prevent list. That's all for threat mitigation and alerts. We encourage you to experiment with different custom prevent lists to see how Jamf Protect can automatically resolve threat events in your environment. Be sure to check the Jamf Protect documentation for more information, and when you're ready, take the Jamf 170 certification exam. Thank you very much for joining us in this course. We hope to see you again soon.